Good morning. It's August 20th, and this is your daily brief in science. Here's everything you need to know. A new form of brain stimulation could change the landscape for Parkinson's disease treatment. Adaptive deep brain stimulation, or ADBS, has shown remarkable results, significantly outperforming traditional constant deep brain stimulation, or CDBS, in alleviating symptoms. Megan Frankowski, PhD from the NIH, highlighted that ADBS could greatly enhance the quality of life for those living with Parkinson's by adapting to their changing needs. In a pilot study conducted by researchers at the University of California, San Francisco, 4 participants alternated between ADBS and CDBS without knowing which method was being used. The results were striking. ADBS reduced the most bothersome symptoms by approximately 50% compared to CDBS, with 3 out of 4 participants reporting an improved quality of life. This innovative approach leverages real-time brain data and artificial intelligence to adjust stimulation levels, functioning like a cruise control system for the brain. Despite its promise, ADBS technology requires further development, including extensive clinical trials and clinician training, before it can be widely implemented. Traditional DBS involves constant stimulation, which can lead to side effects. ADBS aims to mitigate this by providing tailored stimulation based on real-time brain activity. The potential applications of ADBS extend beyond Parkinson's disease, with researchers exploring its implications for other neurological and psychiatric disorders. This marks the first effective closed-loop brain implant for Parkinson's patients, allowing for personalized treatment during daily activities. Professor Philip Starr from UCSF considers this technology the future of deep brain stimulation for Parkinson's disease, reflecting over a decade of research and development. However, experts like Claire Bale from Parkinson's UK emphasize the need for larger clinical trials to confirm the safety and effectiveness of ADBS before it can be approved as a standard treatment. The integration of 3D printing technology in dentistry is transforming the landscape of dental restorations, enhancing accuracy, efficiency, and cost-effectiveness. This advancement is particularly evident in the production of definitive indirect restorations, which include crowns, dentures, and surgical guides. A recent systematic review has examined the mechanical properties of 3D printed composite materials, focusing on their application in permanent indirect restorations. However, the review also highlights significant limitations in the existing literature regarding commercially available 3D printed composite resins and their mechanical properties. There is a critical need for the development of new materials that meet the mechanical, physical, and biological requirements essential for permanent restorations. Additionally, the findings emphasize the necessity for specialized finishing and polishing systems designed specifically for 3D printed dental materials, as current generic systems do not provide optimal results. The nitrogen curing process has emerged as a promising method, yielding superior outcomes in surface roughness and gloss for finished 3D printed dental materials. Furthermore, multi-step finishing and polishing systems have been shown to produce smoother surfaces compared to one-step and two-step methods. The study concluded that reducing layer thickness and increasing post-polymerization times can significantly enhance the mechanical properties of 3D printed resins. Statistical analysis from the research revealed notable differences in flexural strength and hardness depending on varying layer thicknesses and post-polymerization times. Notably, low concentrations of nano-CO2 were found to improve flexural strength, while both nano-CO2 and nano-TO2 contributed to enhanced mechanical properties and reduced microbial adhesion in provisional resin. Among the nanoparticles studied, nano-TO2 demonstrated superior antimicrobial effectiveness, particularly in reducing adhesion of Candida albicans. A recent study has shed light on the intricate world of flavors found in fermented soybeans, specifically those produced by the bacterium Bacillus subtilis BJ3-2 at a temperature of 37 degrees Celsius. This research underscores the vital role of microbial metabolism in flavor production, suggesting that genetic engineering may offer a promising avenue for modifying fermentation flavors. Through multi-omics data analysis, researchers identified two key genes, SDAAA and CAT-X, which are crucial in generating the distinct flavors associated with fermented soybeans. Among the key aroma compounds identified were 2-methylbutyric acid and 2,3,5-trimethylpyrazine, which contribute to flavor notes described as sweaty, roasted, and smoky. Utilizing gas chromatography-mass spectrometry, the study revealed a diverse range of volatile compounds, including 13 alcohols and 19 ketones, that enhance the flavor profile of fermented soybean samples. Additionally, the research explored the potential for improving the flavor quality of soybean protein isolate seasonings through microbial fermentation using Corynebacterium glutamicum. Starter cultures are highlighted as essential for standardizing quality and speeding up the fermentation process across various fermented products, including fish. Fermented fish products are noted for their health benefits, leading to a blend of traditional fermentation practices and modern scientific techniques. The study also found that inoculating shrimp paste with Exiguobacterium profundum, FELA1, and koji improved umami and richness while mitigating bitterness and astringency. E-nose and E-tongue analyses indicated that the inoculated samples exhibited increased levels of pleasant volatile compounds, including alcohols and aldehydes. The flavor profile of fermented fish products is shaped by both microbial and enzymatic actions, resulting in a wide array of free amino acids, peptides, and volatile compounds. The review concludes with suggestions for future research aimed at enhancing the quality and flavor of fermented fish products, highlighting the need for innovative fermentation techniques. A recent study has revealed a surprising connection between how we consume online videos and our feelings of boredom. Researchers from the University of Toronto Scarborough found that constantly switching between videos can actually lead to increased boredom and decreased satisfaction among viewers. The study, published in the Journal of Experimental Psychology, General, involved 7 experiments with over 1,200 participants, including U.S. residents and Canadian college students. The results indicated that participants who were restricted from switching videos reported feeling less bored and more satisfied, suggesting that a more immersive viewing experience leads to greater engagement. In one notable experiment, participants who watched a single 10-minute YouTube video found the experience more satisfying than those who switched between multiple shorter clips. Further experiments reinforced this finding, showing that allowing participants to skip videos resulted in higher levels of boredom. Lead author Dr. Katie Tam emphasized that focusing on content instead of rapidly switching can enhance enjoyment, akin to the immersive experience found in movie theaters. Boredom, often defined as a state where individuals crave engaging activities but feel unable to find them, is linked to a lack of novelty and challenge. Previous research has pointed out that boredom can lead to harmful or impulsive behaviors, highlighting the urgency of addressing this issue. As digital switching becomes more common, particularly on smartphones, it's crucial to understand its impact on feelings of dissatisfaction. Chronic boredom has been associated with negative mental health outcomes, including depressive symptoms and anxiety, emphasizing the need for more engaging content consumption strategies. However, it's worth noting that the study's findings may not be representative of the broader U.S. population, as it primarily focused on Canadian college students and did not analyze the role of short attention spans in contributing to boredom. Recent research has unveiled a promising approach in the field of polymer chemistry, focusing on the design of molecularly imprinted polymers, or MIPs. By combining quantum mechanics and molecular dynamics methods, scientists aim to enhance the affinity and selectivity of these polymers, which can act like synthetic antibodies for targeted molecule recognition. This study specifically targets epinephrine, utilizing advanced computational techniques such as density functional theory and molecular dynamics simulations. The researchers identified acrylic acid as the most suitable functional monomer for formulating epinephrine MIPs, following evaluations using 6 different DFT functionals. They established an optimal molar ratio of 1:4 for epinephrine to acrylic acid, incorporating ethylene glycol dimethacrylate and acetonitrile as solvent for efficient polymer development. In their methodology, quantum mechanical calculations were conducted using Gaussian 09 software, while molecular dynamics simulations were performed with GROMAC's 2018.8 software. This dual approach allowed for an in-depth investigation of non-covalent interactions during the imprinting process. The findings also indicated that the molar ratio of the template to the functional monomer significantly influences the formation of template functional monomer complexes. The study showcases the potential of MIPs in various applications, particularly in the context of cancer diagnostics, where their stability and versatility are increasingly recognized. With global cancer incidence exceeding 11 million cases annually, there is a pressing need for improved diagnostic techniques. MIPs could play a crucial role in this area as they enhance the detection methods for biomarkers essential in screening, diagnosis, prevention, and monitoring of malignant tumors. The review also discusses the limitations and prospects of MIPs in cancer diagnostics, emphasizing their potential to improve accuracy in screening and diagnosis. As research in this field continues, the advancements in MIPs may lead to significant improvements in how we detect and respond to cancer. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.